Hi everyone, welcome back to my Kubernetes Crash Course series. My name is Suraj Singh Rajput. I'm a DevOps engineer and a technical trainer. In this module, we're going to learn about Kubernetes Services, where we will learn about NodePort, load balancer, as well as ClusterIP type of services. So without a further delay, let's move back into video. So let's start our new module that is about Kubernetes service. So we have seen the drawbacks of pod. So we created something called as Kubernetes deployment, where Kubernetes deployment was able to solve the issues of Kubernetes pod. That is auto-healing kind of stuff. But in Kubernetes deployment, we came up with a new sort of issue. That is, once the pod has been deleted and Kubernetes deployment along with the help of replica set will recreate a new pod. But the IP address of this particular pod is lost. So how to solve this issue? So we will check in this particular module, or we will see this issue, how to solve it in this particular module. All right. So the first thing, this is the particular diagram of your Kubernetes deployment. I'll take only two pods. Deployment, pod. All right. I have something called as Kubernetes deployment and two pods has been created. I'll take only two pods, or else let's go with three. Because in our deployment file, we saw three replicas. Let's go with three. So deployment in turn will create what? Replica set, that is RS. This will help us to maintain all the pods. All the three pods will be maintained with the help of replica sets. He'll maintain the minimum state or desired state of pods. So when the pod is deleted, it will be recreated with a new address of IP. That is when we start to have an issue. Right? That is when we started to have an issue. So in case, if you remember my Kubernetes deployment file, there we saw in deployment file, in deployment file, I had something called as labels, right, and selectors. It plays very important role. If you observe the deployment file of Kubernetes, there it has been clearly mentioned labels as something, you can give any label, but make sure labels and selectors are matching. Right. So let me give in this way. See, here in this particular page, we cannot prevent neither the deletion of pod nor the replacement of IP addresses. We can't prevent both the things. But what if I can provide a label to this particular pod? I'll give a particular label to the pod. When I say label, all the three pods will be having the same label, because in deployment file, I clearly mentioned all the pods should be come up with same label. That is something called as Nginx. I'll show you in practical. That means all the three pods as what? Nginx as a label right now. Right. Next, this is what deployment does, and pods will be deleted, it will be recreated. Enter service. What it does is, service will be created on top of deployment. Service will be created on top of deployment, and service doesn't create any pods. Don't get confused. A service will not create any sort of pods. Any sort of pod creation will be done and taken care by your pod or Kubernetes deployment only. He will create a pods and he'll maintain the pods. But service, on the other hand, I'll show the file of service, a service YAML file. Inside this, we will be writing something called a selector. We will write selector, and we will mention the same selector or same label of this Kubernetes deployment. For example, in Kubernetes deployment, I might have written a label as what? Nginx. In my service file, I will write what? In my service file, I will be writing my selector as Nginx. So what it does is, service, it doesn't bother about the IP addresses. The pod might have been any IP address, it might have crashed multiple times, it might have replaced multiple times, but what service does is, he will always be looking for the label. Can I say? It doesn't matter how many times I delete this pod or how many times the pod has been deleted and replaced, names of the pod remains the same because I specified clearly in the deployment file, the names has to remain same. Yes. In my deployment file, I clearly mentioned the name should be Nginx. So what he does is, he will make sure the newly created pods will have the same label. Who will make sure? Deployment will make sure. Once the pod has the same label, even though it has been deleted, replaced a number of times, service, when searching for, or service, when it is implemented, he will not look for any sort of IP addresses, rather than he will be looking for name of the pod. In this way, it doesn't matter what is present inside this place, inside the pod, or what is the IP address of the pod. It will always be, what it does, he'll reach out to the pod by using the name. Correct. This methodology, this new feature is available in your Kubernetes service file. Right. So let me clear this one. Let me draw the diagram clearly, and we'll try to understand what it does here. Right. So first things first, let me take it. So this is the thing, people. This is the proper diagram of your Kubernetes service. This is deployment. It will in turn create replica set. What is replica set? It is a default controller created by control manager. He will in turn create a pods. That is, replica set and deployment is responsible for maintaining the desired state of the pods. And on top of this, a service will be created. Like I said, service doesn't create any pods, it feeds on the pods of a deployment. Right. So in deployment, we have clearly written, the labels for the pod. I'm using Nginx. And when the pod has been deleted, replaced with the new pod, service, when it tries to reach out to the pod, he will be looking for the name of the pod rather than IP addresses. He will never be looking for the IP address, he will be looking for the names of the pod. In this way, even though the IPs has been replaced, you will be able to reach out to this particular person. Alright people, so what we'll do is, let's try to understand what issues is solving. As it says, yeah, pods are ephemeral in nature, yes we know, and their IPS address changes. That is what I explained here. A service maintains a consistent IP. Yes, when we create a service, I'll come back to that one. There are three features or three types we will get it inside a service. ClusterIP, NodePort, load balancer. We'll check all the things. So it will maintain the consistent IP, and because of that, we can have reliable communication within the cluster. How it works, we'll try it. Observe. When we create a service, a cluster IP is formed. Means a common IP is formed. And this IP, or whenever a user tries to connect to a pod, he will not be trying to reach out to this pod by using the pod's IP address, because as I discussed, pods will be frequently deleted and recreated, but instead of that, he uses service IP, that is in other terms called as cluster IP. Once we implement this practically, I'll show you. So this user will take a help of ClusterIP to reach out to the pod. So once this user accesses, or once this user tries to access the ClusterIP, the request will be sent to service. The service in turn will reach out to the pods based on their labels. Rather than IP addresses, service will in turn reach out to the pods based on their labels, not your IP addresses. Right. Now, alright people, so let's try to understand one more familiar term or one more new term that is called a service discovery. Alright people, let's try to get familiar with a new terminology called as service discovery. It is very important. See, I did mention your service will try to reach out to your pod based on your name or naming convention of the pod. You will try to reach out. Right. This Kubernetes uses service discovery to enable communication through things. That means the way or the method by which service tries to identify the names of the pod, even though the IP addresses has changed, this is what we call it as service discovery. Because once the pod is lost, recreated, IPs have changed. But service still tries to reach out to this pod by using the IPs. This communication, the medium of communication, is what we call it as service discovery. The same things has been mentioned. Kubernetes uses service discovery to enable communication through stable service names instead of IPs. They put it in a different definitive manner, but I try to simplify this thing in this way. So it is one of the important things that you can remember while attending interview. What is service discovery and how service discovery happens. Right. Now, like I said, Kubernetes service offers 3 different features. Like I said, Kubernetes service offers 3 different features, out of which first one is ClusterIP. Next one is NodePort. Another one is load balancer. We will try to understand one by one all the things. So let's check how it goes. One more thing. So by default, whenever you create any Kubernetes service, it will be in your ClusterIP by default, right? And you can see it has been written. This is a default service type in this one. Right. So what it does and what do you mean by internal IP addresses and Kubernetes cluster? This thing we'll try to identify or we'll try to understand with a practical session. Okay. So this is a default service type, and you can observe there it exposes service on an internal IP address. So what do you mean by this? Let's try to understand the particular diagram now. So if you observe, this was my Minikube architecture. Control plane, worker plane, where pods were running. Right. When you implement a service, it will create something called as ClusterIP by default. Right? Let me explain. Right now, we will go into our server. We will create a service. By default, it will create a ClusterIP. Right? And if you want to access the pods which are running inside this one via service, this is a service which will sit on the top here. Of course, beneath this it will be deployment and all. If you want to access this service, what we do is we have to enter in this thing. Means we have to enter the worker node properly, right? Then only you can access your service. That means the cluster IP of the service will expose the service within the internal structure. Within which place? Within the internal structure. That means within only this node, within only this or within this internal people who are working internally can access this one. That is what it meant by your internal IP addresses. Correct? and the service is only accessible from the other pods and resources inside the cluster, not from outside. That is what I was trying to explain, right? And you can ask me, who's gonna provide access to inside this cluster? How can we access this one? And how can I give external access? All these things are a part of something called as role-based access control that we will be discussing in further sessions. Stay tuned. But right now, hope you understood what ClusterIP does. It exposes the service within internally, right? So if I have to explain what is expose and kind of stuff, right? At some point of time, we need to expose our application to an external world, right? In order to expose the application to an external world, we use this K8s service. That is one of the other features of K8s service, rather than, apart from solving the issue of Kubernetes deployment, service is also used to expose the applications to outside world, correct? Apart from solving the issues of Kubernetes deployment, we expose applications to external world by using Kubernetes service. So that is what has been mentioned here. The service can only be accessible within the cluster, not from outside. Yes. So in service, we got 3 points, that is ClusterIP. Another one is what here? Next one, NodePort. Next one is load balancer. I will discuss one by one, but this ClusterIP doesn't have capability to expose your application to a outside world, right? What do you mean by that? We'll try to understand that one. But as you can see here, it is clearly mentioned only inside the cluster. People who has access inside the cluster can access your application. But that is not how the real-time environment works. Nobody is going to give you access to Flipkart applications directly inside their servers so that you people can access, right? No. So they will expose this environment, but how this environment is exposed, we will just check in the next slides. All right, people. If you try to move on from ClusterIP, we will move on to NodePort, where NodePort will allow NodePort, of course, it is also a part of service which helps us to expose the application to which place? To an external world. But NodePort helps us to expose the application to an external world outside the cluster. In the previous type, which is ClusterIP, you can access the application within the cluster. But as you can see here, allows external clients outside the cluster to access the service. Correct. But what is this NodePort and how it works? Let me draw a proper diagram. There will work. And one more point. If you are exposing, it will be or it should be exposed well within this particular range. Right. You cannot go outside this particular range. Right. And what happens is, this is the thing. Here I have a Minikube node. I got Minikube node. In cluster type of IP, user have to enter internally to access the pod which is running there. In cluster type, user has to enter Minikube to access the things. But in case of NodePort, this pod will be exposed on this node or outside this node. That means this user need not to have access to this port or need not to have access to this node directly from outside. Even though he doesn't have access to this node, even though he doesn't have permission to enter inside this worker node, he can still access it from outside of the cluster. Got it? So when exposing this particular pod onto your node it uses a particular port range of this one, right? When I said NodePort will expose your Kubernetes pod onto your cluster, that means it will do something called as port mapping. It will do something called as port mapping. He will map the cluster port with the pod port. So generally what happens is the cluster port of 30,000 to this particular range will be mapped with the pod port of 80 or on whichever the port your application is running inside a port. Correct? So let's check these two things right now practically, and coming back to load balancer, I'll explain this once we check normal ClusterIP type of service and NodePort type of service. But first we will go and we will check something called as ClusterIP type of service. Alright people, first things first, like I said, service has to be created on top of deployment, right? So do I have a deployment right now? Let me check. So currently there are no pods in default namespace, and if I check kubectl get deployment, there also I don't have anything. So what I need to do is, let me go back and let me create a deployment once again. Immediately after that, we'll try to create a service. So in order to create a deployment, I do already have my file. I just have to create something called as, I need to execute this one, then I'll create a service YAML. For that, kubectl Alright people, as you can see here, our deployment is ready. Now immediately on top of this, let me create my Kubernetes service file. For this, I do have this particular file here with me. This is my Kubernetes service file. Let me copy this YAML details and let me go here, vi service .yml, and I'll just paste inside this one. And remember, your name has to remain same. You see, your name has to remain what? Same. Nginx and Nginx deployment. That is just a name of a service. Oh, great. So you can check it by using cat. There will see everything's fine. Kind is changed to service. Nginx deployment. App is same. You can check in deployment also. Can you see? Labels is Nginx. That is the reason in my service also, inside my service also, I'm using the same label or same selector. Here also they already used same selector. Where is this one? Selector app Nginx. If you miss, that will be a problem for us. So now, before I apply this particular service file, let me give this particular command, kubectl get svc. See, when I run the command kubectl get svc, don't bother about this one. It is Kubernetes pods and Kubernetes clusters thing. We haven't created yet our Kubernetes service. This is of your default Kubernetes cluster. What I'll do is, and you observe there is something called as external IP and ClusterIP. Always ClusterIP will be of internal, external IP of a external thing. Just remember this. We'll discuss in detail about this external IP in few slides or in next options. Now, kubectl apply -f. Can you see? I have created what? Service. And if I do the command kubectl get svc, can you see? This is my service name, Nginx deployment. Which type of service has it created? ClusterIP. That's what I said, right? By default, which sort of ClusterIP will be created or which sort of service will be created? ClusterIP. And he has allocated particular IP address. That means here I have created this particular thing. It is a default service type and it has already exposed your application internally. The only thing is, let me go and let me try to access this particular stuff now. Now, how we can do? Like I said, if you create default cluster IP, you should enter into Minikube worker node or Minikube node. There only you can access this particular stuff. But before this, let me tell you, kubectl get pods, kubectl get pods, -o wide. How many pods are there? 3 pods are running. What are the IP addresses of the pod? 8, 9 and 10. Right. So now I'll do this thing. Minikube SSH. I've entered. Okay, sorry. So I forgot to note down the IP of this one. SVC. Yeah. Now I'll do Minikube SSH. Alright, people. Earlier, as we can see in Kubernetes deployment, we used to enter in the same manner, similar manner, and we used to access Kubernetes pods by using their own IP addresses. Matlab individual IP addresses we used to use to access the pods. But in this case, if you observe properly, I won't be using the pod IP addresses because I no longer bother about pod IP addresses. I will simply use the cluster IP. I'll copy this IP. With the help of this IP, I will be accessing my Kubernetes service. Service in turn will help me to access which one? All the pods. Correct. But you have to log in inside your worker node. Can you see? I logged in inside worker node, Docker Minikube. Then only you will be able to access. Reason for that is we have created which type of service? Cluster IP type of service, and this can only be accessed inside which one? Internally. Right. So let's check it. For that, curl http. I'll use this IP address. That is 10.107.20.186 and I'll use a port number 80 because as you see it has exposed on port 80 TCP. Correct. Can you see? Welcome to Nginx. Same thing is for me. But the catch here is, since I'm using cluster IP, this IP I'm using here, it might have redirected my request to any one of the pods, right? Correct? I'm not using any one particular IP. And since I'm using this cluster IP, it could have sent to any one particular type of pods. I don't need to bother. Can I say, in a way, it is giving me load balancing? Yes. So that is the reason in Kubernetes service, the cluster IP or NodePort or your load balancing, that is a third part. So this entire stuff, we deem it as what? Load balancing capabilities. Right. So now, if I exit from here and if I delete these pods multiple number of times, and if the pods been created multiple number of times also, it will not affect your cluster IP. Right. Let me show you that one. What I'll do is SVC, let it be there. I'll go with O wide. And let me delete all the pods one by one. Of course, again, don't try to delete deployment. It will not work for us. I'm deleting all the pods. I just had this data. I'm deleting all the pods. Can you see, people? What is the IP addresses? 8, 9 and 10. What are the IP addresses now? 11, 12 and 13. Right. Even though these things has been deleted, we don't need to bother. We can continue there and it'll continue to work. Let's check it. What I'll do is, I'll do minikube SSH and I will still be using the same cluster IP. Can you see, people? Still it shows the same web page. Even though I have deleted all the pods and all the pods got replaced with the new pods, but still you are able to access. So in this way, Kubernetes service has solved the issue of load balancing, kind of in a way load balancing, and at the same time we have solved one more issue, that is your service discovery. Earlier, if you share a particular IP address with your colleagues and if they try to do SSH or login into your pods, it never used to work because pods has already been replaced. But by using this particular stuff, that is your, which one? Kubernetes service, we are able to solve this particular issue. Until and unless you delete this Kubernetes service, just like how we did for deployment, this service will hang on to single IP address. Yeah. Can you see, people? This is where I discussed with a consistent IP address. That means once you create this one, it will be fixed until unless you release this particular IP address. Hope you understood what is your Kubernetes service and that too specifically cluster IP type of Kubernetes service. So alright, people, let's move on to NodePort type of service, right? Like I already explained, if you are using service cluster IP, you have to enter your minikube worker node, or you can access your pods only internally. But if you want to expose your application to an outside world or outside the cluster, we should use what? NodePort type. So for this, I have a script. Let's go ahead. Let's try to execute that particular thing. When I say script, I was talking about Kubernetes manifest file. So before I move ahead, let me show one more thing. kubectl get svc. People, observe here. When I do kubectl get svc, you can clearly see Nginx deployment and here it says cluster IP. Like I said, it is a default thing, even I can't help, can't change. Now, what I'll do is, I will create a new file that is your NodePort type of manifest file. I'll try to implement that one. Then we'll try to understand what is happening in this particular space. Right. Now, first things first, I do have a Kubernetes, this file. Let's go back. I do have a Kubernetes service with NodePort type of file. Let's go back, let's create that particular file. Let's try to implement it. Alright, people. And here also you can see the only change what I have is app is still Nginx, right? Let me save and come out from here. People, you can see there, port is still, my application is running on port 80, target port is also 80, and my application will be exposed to the outside world on the port number 31,000. And service will identify this port by using the selector called as what? Nginx. And label is also Nginx. Right? And compared to your service file, the only new addition inside a file called as service with NodePort is type NodePort. There we never described anything. So by default he took what? Cluster IP. And one more thing is NodePort number. Type NodePort and another one is NodePort number. Except for these things, nothing is changed. Let's go and let me implement this file and let's check what changes will happen in this particular space. Observe, I have highlighted clearly what will happen to cluster IP. Can you see, people? He says it has configured, and immediately I will check get SVC. You see, people? It has changed for what? Instead of cluster port, instead of cluster IP, now he says node port. Correct? Yes. So this is what we wanted to check it, and you can observe one more thing. It has done port mapping where port 80 is connected to 31,000 port number. You see here it was port 80 and this is what happened. That means if any user from outside tries to access this port number like 31,000, it will be redirected to port 80 of a pod. Right. But there is a question here. How do you access from outside? How do you access from outside into this particular stuff? Let's move ahead. Let's try to understand. So for this, see, the pod has been exposed to the public on a node port, correct? So they have clearly mentioned the port number of node also, that is 31,000. So we should be able to access the node port IP address. Then by using node port or by using node's IP address and node port number, I can redirect myself to pod. Observe, by using node IP address, that is minikube worker node's IP address and node port number. Right. So what is minikube's worker node IP? For this, we can use a command minikube IP. What is the number? 192.168.49.2. Right. And what is the port number? As we saw, 31,000. Let's go and use all these combinations. Let's check will it work or not. So CURL -L. What is IP? 192.168.49.2 colon 31,000. Moment of truth, whether they're exposed or not, let's check it. All right, people, now you got to see what happened here. I need not to enter inside my cluster to access this one. It has been exposed to outside world. Got it? So this is what we achieve by using Kubernetes service node port type, right? But it is a later version or one of the other features of service, but the default feature is ClusterIP. But we're using which sort of feature? A next feature called as NodePort. There is one more feature there, that is what we call it as load balancing. The name itself is a proper load balancing. What is this? Let's try to understand right now. Right. So remember, I asked you people to remember this thing. What does he says? External IP, he says what? None. Correct. So now what I do is, I will open my service file, that is by using service file, and I'll change this node port to a load balancing. How I do it? Alright, people, can you see here? This is the proper description of these things. And if you keep on moving down, what does it say? Node port. Right. Alright, people, so that is how your node port works. Now let's move on to proper load balancing type of thing. Let's try to understand how to change this thing and what features does he offers. Right. So here we will come across a concept called as Cloud Controller Manager, which we discussed in the architecture. So here I'll try to relate that particular topic in this thing. Let's check it. So as of now, what I'll do is I'll do something like edit the ongoing service. And this is what the description and all the things looks. I'll go to this place which says type as NodePort. I'll try to edit it to a load balancer. Right, and he has accepted clearly. And if you observe that, when I run kubectl get svc, right, we get what? No external IPs. And what does he says? Something called as pending. Right. So we might be arguing, see, NodePort only exposed my application inside or outside the cluster. But I'm using cloud here. I couldn't access that. If I have to access my application on an internet or via cloud options, what I need is I need a proper external IP. Right? Of course, that feature is not there in Minikube. That is the reason we use external IP, and this, the work or who's going to assign this external IP for me. Right? This is where we come across cloud controller managers. Any sort of work that is related to cloud on our Kubernetes cluster will be taken care by our cloud controller managers. But unfortunately, I couldn't assign type of IP address here. That's one thing. And one more thing, if you observe, it has changed from NodePort to which place? Load balancer stuff. All right, people, hope you understood what is service and how these things are solved. But before we move ahead, let's try to recap this one, what is going on here. Right. So first things first, what we learned? In deployment, we had an issue. The issue says we can create auto healing by using deployment, but the issue of IP replacement was not able to solve with the help of deployment. Then what we did, we came up with service. By using service and labels and selectors, we were able to solve the issue of our, which one? IP replacement. Because service identifies the pods by their names, not by their IP addresses. That is one thing. So there, our service offers three different features, that is ClusterIP, NodePort, as well as load balancer. So ClusterIP, yes, it is used to access the pods within the cluster, I mean inside the cluster. If you want to access this outside the cluster, use what? NodePort. Then if you want to access on a cloud or any work which is on the cloud, that will be handled by cloud controller, right? So this is what we learned in Kubernetes service options. We will end this Kubernetes service here and we will see you in the next module. Thank you very much. If this session has helped you learn about Kubernetes, do hit like, share and subscribe button for Star Ajay. I will meet you in the next video. Till then, keep learning.